So this video here is going to be an introduction to the basic trig functions, sine, cosine, and tangent, and how to use them and their inverses to find the sides or the angles within a triangle. And we're doing this because in physics, you use a lot of vector addition, and you need to be able to take a value and break it into its components and get an angle for like a total, or work backwards and get the other way around. So to start off with, we're going to have the trig functions and then their inverses. Alright, so the left-hand column we have all of our basic trig functions, the right-hand column we have the inverses of them. Now what do you use each of these columns for? Well, this column over here is going to be finding the side. The column on the right-hand side is going to be used for finding an angle. Now, both of these things, in this left-hand column, the sine theta, cosine, tangent theta, when you plug this into your calculator, you're going to get some kind of a decimal value. And that decimal value is going to be equivalent to the ratio of the sides. Now this right-hand column, it's going to be the inverse function. Now the inverse of that ratio is then going to get you to the angle itself. I'll go ahead and do some practice problems with this and help you be able to identify what's opposite, what's adjacent, and what's hypotenuse. So on the right-hand side, I'm going to go ahead and put in a triangle with those values labeled. Alright, so we have our triangle drawn, and the sides and the angle labeled. So the hypotenuse is always the longest side of your triangle. The opposite side is wherever theta is, look to the opposite side of the triangle. That is going to be the opposite side. The adjacent side is the one that's not the hypotenuse. That is touching theta. Important thing to notice here is this is a right triangle. In order to use these functions, like they are shown here, it needs to be working on a right triangle. If we have a total value for a vector, and we're breaking into its components, we are indeed making a right triangle. Same thing if we have x, y components, or even z components, those should all be at right angles to one another, so that should be a right triangle to be able to use trig to get back to the hypotenuse. Now the next page, we're going to go ahead and run through a few examples of these, finding the sides and finding the angles. Alright, so now that we have our triangles, we want to go ahead and identify our sides and our angles. So for this one, theta is in the bottom left-hand corner. Now our longest side is going to be our hypotenuse. The side touching theta that's not the hypotenuse is the adjacent. And the one left over on the other side of the triangle is the opposite. Next one down, theta again, bottom left-hand corner. Longest side is up top. This is going to be our hypotenuse. Other side of theta, this is opposite. And the angle touching it, that's not the hypotenuse, again, adjacent. Now the bottom triangle, theta is in a little different location. It's the top right. So we look again for the longest side of the triangle, which would be down here. Where theta is, the one touching it is going to be adjacent. And on the other side of the triangle, this is opposite. So now we have the sides identified. We need to look at what trig functions we're going to use for each one. Alright, so for this top one, we have the adjacent side and the hypotenuse. So we're going to go to the cosine function. And since we're finding an angle, we're going to use the inverse cosine function. Plugging in our values, it's going to be 12 over 13. And that comes up to 22.6 degrees. Now for the next one down, looking at theta again, we have the opposite side and the hypotenuse. So instead of cosine this time, we want to use sine. And again, it's going to be the inverse of that function. That one comes up to 23.6 degrees for that theta. Now for the bottom one, with theta being here, we have the opposite side and the adjacent sides. So we're going to use inverse of tangent. And 38.7 degrees for that one. Now the next step, we're going to go ahead and recreate 3 more triangles, and this time, instead of using the inverse functions to figure out the angles, we're going to use the regular function, or regular versions of the functions to figure out one of the sides of the triangles. Something to keep in mind here too is we didn't solve for the third side of these triangles. We could have easily done so by just using the Pythagorean theorem. Alright, so now we have our 3 examples. We're going to go ahead and figure out what one of the sides is given a side and an angle. So the first thing we need to do is identify the sides based on where theta is. So for this top one, the angle is located in the top left-hand corner. The longest side is again going to be our hypotenuse. The side touching theta is then the adjacent side, and the one left over is the opposite. Middle one, the angle is the bottom left-hand corner. Opposite of that is going to be our x. The long side is our hypotenuse. And the side touching theta is the adjacent. Now with the bottom one. The angle is 37 degrees. The long side is the hypotenuse. The side touching the angle is again adjacent, and the one we're looking for is opposite. So now we need to determine which trig functions we're going to use. Since we have adjacent, we're looking for the hypotenuse. That means we're going to go with a cosine function. Now for the next one down, we have the adjacent side, and we're looking for the opposite side, so that means we're going to want to use tan. So there you get an 8.1. And for the bottom one, we are looking for the opposite side, and we have the hypotenuse. So that's going to be sine. Alright, so that answer comes out at 6.2. So this is your crash course in the basic trig functions, how to find the sides and angles of triangles based on whether or not you're using the standard form of the trig functions, the ones in the left-hand column there, or if you're using the inverses, the ones in the right-hand column. That's pretty much it for this video. See you next time.